Hello guys, welcome back to PhiloEduce. So in the last video we have seen the introduction of the surface chemistry as well as the adsorption, adsorbate, absorption with distinction between absorption and adsorption and such things. And in this video we are just continuing through the mechanism of the adsorption, type of adsorption, as well as the comparison between or distinction between the Physisorption and Chemisorption. So without further delay, let us go through the videos. So first, mechanism of adsorption. So mechanism of adsorption. So last time we have seen that for a adsorbent molecule is adsorbed. So why this adsorbate molecule is attracted to the adsorbent. Adsorbent and adsorbate. I hope you remember. Wait, okay. And so why this is attracted? What is the driving force of this adsorption? So when we look at the adsorbent molecules, we can see that suppose this is the adsorbent molecule, and when we look at the particles, so these are the particles of the adsorbent material. So the environment of the surface particle and same environmental and of the bulk particle are not same. So I will explain that like this. So suppose this bulk particle, so this is the bulk particle, so this is surrounded by other atoms like this. So here the forces are balanced or mutually balanced. Okay, but you look at the surface particle of like this, but when we check, these are surrounded by these molecules on the downside, but the upside these molecules does not have any particles, so environment is different, so there creates a unbalanced force or also known as residual force. So this residual force, due to this residual force, a surface energy creates and that attract the adsorbate molecules. Okay, I hope you understood. The environment of the bulk particle and the surface particle are different. So this surface particle have a unbalanced force or residual force. Due to this residual force, the adsorbent molecule, due to these forces of adsorbent, they are responsible for the attracting the adsorbate particle on the surface. Next thing is that we have seen the main driving force is the unbalanced or residual force. So the residual force is increased on the new surface. So the adsorption or extent of adsorption increases with the increase in surface area. Suppose this cube of 1 kilogram or 1 gram having a side of 2 centimeter. So when we calculate the surface area, it is 24 centimeters square. Let's cut this into 8 small cubes of 1 centimeter. When we calculate the surface area, it is 48. So almost doubled. So as we said, the surface area increases adsorption also increases. So that's why there's an application for this adsorption, that finely divided particles can show much more adsorption than that of the large systems, since the surface area is increasing. Next thing we have to look is the little thermodynamics, like the main three things: delta H, delta S, and delta G. So another important factor for adsorption is that heat of adsorption. So during adsorption, there is always a decrease in residual force of the surface. Also, residual force, or there is a decrease in the surface energy. So this decrease in surface energy, I'll represent it as SC. The decrease in the surface energy is shown as, appears as a heat, or heat liberated. Heat is liberated there. So when the heat is liberated, we can term it as exothermic reaction. You may know that. So again, for a exothermic reaction, we know that delta H is negative. Okay. So we say here delta H is negative for a adsorption process. Delta H of adsorption, enthalpy of adsorption, is negative. Next, let us look on to the entropy. So usually gas molecules are spread like this, and when there is a adsorbent coming through, and gas molecules will be ordered, so the freedom will be restricted. So when the freedom is restricted, the delta S will be negative. Delta S will be a negative value. So the adsorption is accompanied by the decrease in entropy as well as the decrease in enthalpy. So we know that for a process to be a spontaneous process, delta G should be negative, and the value of delta G, we know that it is delta H minus T delta S. And now we have seen that this is a negative value and this is a negative value. So if you already notice that here there is a negative, and delta S is also a negative value, so this overall term will be a positive value. So in order to become delta G a positive value, the condition is that a delta H should be more negative, such that delta H should be greater negative than T delta S. Okay, otherwise it will result in a positive delta G value. Okay, I hope you understood. So as the adsorption proceeds, the delta H become, so suppose the delta H is a high negative value, and as the adsorption proceeds, the delta H become less and less negative, and ultimately it becomes equal to T delta S. So what happens? Delta H minus T delta S. So here delta G becomes 0, or equilibrium, state of equilibrium is attained. Okay, equilibrium is attained. So I hope you understood this. So let us go to the next. Next is type of adsorption. So Suppose this is a adsorbent and this is a adsorbate. I'll change the color to red. Suppose this is adsorbate. So depending on the bond or depending on the attraction between these, we can divide it into two. First is physical bond, like physical adsorption or Physisorption, when there exists a van der Waals force, van der Waals type weak attraction. It is a weak attraction, as you know. Or when ionic or covalent bond is occurring, it will result in a chemical adsorption or Chemisorption. Okay, here the bond will be ionic or covalent. Since the chemical bonds are formed, for a formation of a chemical bond, there needs a activation energy. So these are also often called activated adsorption. Activated adsorption. Sometimes both of these physical and chemical adsorption will be occur simultaneously. And another thing is that sometimes when a physical adsorption at a low temperature may pass to the chemical adsorption as the temperature is increased. I will explain it with an example. Suppose a nickel surface. This is a nickel surface. So here at low temperature, a hydrogen molecule, I will show this as a hydrogen atom, connected hydrogen atom. This will be physically adsorbed. Here it is physical adsorption. I will represent it as Pa. Okay, here physically adsorbed as molecule itself, it is physically adsorbed to the nickel surface, and when it is heated, suppose, okay, and when it is heated, it will be changed to chemical adsorption. That is, the hydrogen will get dissociated and forms a bond, nickel hydride bond, forming a chemical adsorption. Hydrogen atom nickel bond, hydrogen atom nickel bond, and forming a chemical adsorption, just like this. So here the Chemisorption, Physisorption is converted to a Chemisorption. So this may happen as the temperature is increased. So now let us look on to certain characteristics. Now first let us look onto the Physisorption. So first point is that it has a lack of specificity. Okay, so for a given surface of adsorbent does not show any preference to the particular gas of the particular gas. So for Physisorption, for a particular gas, it does not show any preference, since the van der Waals forces are universal for almost every gases. So it does not show any specificity for any particular gas or preference for any particular gas. So this is mainly due to, since it is due to the van der Waals, weak van der Waals force is very universal. Van der Waals force, universal van der Waals force. So there is no preference. Okay, that's the first point. Let us look on to the second point, that is nature of adsorbate, not adsorbent, adsorbate. So here the amount of gas adsorbed by a solid depends on the nature of the gas. Okay, so what nature it is depending on, like easily liquefiable gases. Easily liquefiable gases, that is what are the easily liquefiable gases? Liquefiable, easily liquefiable gases, that is a gases having a high critical temperature. Okay, easily liquefiable gases readily adsorbs on the adsorbate molecules. The adsorption takes place very readily. So let's see some examples for this. Consider a activated charcoal. Activated carbon or activated charcoal, and consider the gas molecules SO2, methane, hydrogen. When we look at the critical temperature, we can see that it is for SO2 it is 630 Kelvin, very high, and for methane it is 190 Kelvin, and for hydrogen it is 33 Kelvin. So we have said that easily liquefiable gases or gases with a very high high critical temperature readily adsorb. So adsorption will be higher for this SO2 than the methane than the hydrogen. Okay. So first factor was the lack of specificity. Second factor was the nature of adsorbent. So nature of adsorbate. So adsorbate that having a higher critical temperature or easily liquefiable gases are readily adsorbed like SO2. So next characteristics is the reversibility. They are Physisorption are reversible in nature. So that is a adsorbent solid and gas forming a gas solid. In the first lecture we have seen that we can represent it by a slash or hyphen, adsorbent, and plus, since as we said it is exothermic, it produces heat, so we say that it is reversible. So this process is reversible. So when it is reversible, we know that it will obey the Le-Chatelier's principle. Le-Chatelier's principle. Okay. So according to Le-Chatelier's principle, so see, this is gaseous molecule. So here, when the pressure is increased, the forward reaction will be favorable, or when the pressure is decreased, backward reaction will be favorable. Desorption will be occurring. Okay. So gas can be removed by decreasing pressure like this, and adsorption can be proceeded. The forward reaction can be proceeded by gas is more adsorbed by the increasing the pressure. Another method or another thing is that when the temperature, so here we see that it is exothermic, and here there is a heat is produced. So the physical adsorption occurs readily at a room temperature, but when the temperature is increased, the adsorption will be decreased. Okay, this is also according to the Le-Chatelier's principle, since there is here heat is exothermic process, heat is produced or it is exothermic process. So next thing we have to look is that surface area of the adsorbent. So surface area is the adsorbent. We already said that as the surface area increases, the extent of adsorption also increases. So that's about the surface area. So finely divided metal or porous substance have large surface area, so they are good adsorbents. Okay, and then comes the enthalpy. So enthalpy of adsorption. So as we already said, the physical adsorption is also an exothermic process, but its enthalpy is quite low. Low enthalpy of adsorption is there. So it is around 20 to 40 kilojoules per mole. Okay. So why this is having a low enthalpy? We can say that the attraction between the gas molecule and solid surface is only a van der Waals forces. Van der Waals force is occurring in between them, so the enthalpy is also very less. So now let us go to the characteristics of the chemisorption or chemical adsorption. Chemisorption. So for chemisorption, we can say that it is having a high specificity. Not all molecules cannot show chemisorption, so it is highly specific. It will occur only there if there is some possibility of chemical bonding between the adsorbent and adsorbate. So a chemical bond should be formed between them. Okay, for example we can see that for oxygen it should form a metal oxide bond. Okay, oxide formation should be shown, and for hydrogen it should form a metal hydride bond. Like previously we have seen that for nickel forms a hydride bond like that. Okay, that's about the specificity of the chemisorption. Next, going to the irreversibility. Irreversibility. So in the previous case, Physisorption, we have seen that the Physisorption is reversible, but in the Chemisorption involves a compound formation. So this is usually an exothermic process, and it will be irreversible also, reversible in nature. And another thing is that even if it is exothermic process and at a normal temperature, the reaction will be very slow. But as the temperature is increased on account of the high energy of activation energy, like most of the chemical bond formation, so since the chemical bond is formed, the adsorption also increases as the temperature is increased. So adsorption often increases with the rise in the temperature. So as we already said, the physical adsorption adsorbed at low temperature, when we heat it may change to chemisorption at high temperature. And usually the high pressure is also a favorable condition for the chemisorption. And next, going to the surface area. Surface area is similar to that of Physisorption, and we already said that chemisorption also increases with the increase in surface area of the adsorbent. And the last one, as we said, it is enthalpy of adsorption. Enthalpy of adsorption, since there is a chemical bond forming. The previous time it was a van der Waals force. Since it was weak, the enthalpy was less. But here it is a chemical bond formation. Since it is a strong bond, it will form a adsorption, and the enthalpy of chemisorption will be ranging from 80 to 240 kilojoule per mole. So that's it for the characteristics. So let us compare all of this and try to conclude this video with this comparison. So let us compare between the Chemisorption and Physisorption. Physisorption and Chemisorption. Okay. So this will be a summary of today's session also. So let us look. So in the first we have seen that mechanism of adsorption. So it is due to the residual force the adsorption is forming, and then we see the enthalpy, entropy are both are negative, and the for the delta G should be negative, the delta H should be sufficiently negative than since the T delta S minus T delta S will be a positive value. We have seen that. Then we look on to the type of adsorption, Physisorption and Chemisorption. We have compared the characteristics. So this will be the characteristics as well as the comparison between the Chemisorption and Physisorption. Let us look. The Physisorption or physical adsorption is arises due to the van der Waals forces, a weak type forces, and the Chemisorption is by the chemical bond formation, and it is not specific in nature, and chemical adsorption is highly specific in nature, and Physisorption is reversible whereas the Chemisorption is irreversible. And the Physisorption, it depends on the nature of gas. How it is depend on the nature of the gas? The more easily liquefiable gases, or the gases which having high critical temperature, remember SO2, like high critical temperature adsorbed very readily. And for chemical absorption or chemisorption, it also depend on the nature of gases. So how it is dependent? The gases which can react with adsorbent shows a chemisorption. Remember, oxygen and hydrogen are like it should form a hydride or oxide bond. Next is that for physisorption, the enthalpy of adsorption is low, like around 20 to 40 kilojoule in the Physisorption's case, whereas the enthalpy of adsorption is high for the chemical adsorption, around 82 to 40 kilojoule per mole for the chemisorption. Next is at low temperature is favorable for the adsorption for physisorption. It decreases with the increase in temperature. Physical adsorption decreases, physisorption decreases with the increase in temperature, whereas since in the chemisorption chemical bond is formed, the high temperature is favorable for adsorption, and it will be increases with the increase in temperature. So it is due to the activation energy. So next point is activation energy itself. High activation energy is required for the chemisorption, whereas no appreciable activation energy is required for the physisorption. And next is that it depends on the surface area. Both of them are dependent on the surface area, and it will increase on increase in surface area in the both cases, physisorption and chemisorption's case. And next is the physisorption will result in a multimolecular layers on the adsorbent surface under high pressure. But even under high pressure itself, the chemisorption will only result in a unimolecular layer, since here only chemical bond is formed. So here physisorption shows a multimolecular since it is formed by a van der Waals interaction. Thank you for watching this video. If you like this video, please consider subscribing to our channel, and if you have any comments, please put it on downside and share it with your friends. Thank you.